Hello, my name is Alana and I am a junior at UNC and I'm applying to be a chemistry ULA. One thing about me is that I foster kittens. I've currently fostered around 14 kittens and I would love to be a chemistry ULA because I know chemistry at UNC can seem like a very difficult subject no matter what grade you're going into or what chemistry you're going into. And I know that everyone learns a different way, so it just takes some help to figure out how people learn best for chemistry, because I know that it might not necessarily be the same as how they learn bio or physics. And I have also had really amazing ULAs in the past, so I just want to give that back to my peers. And then some study and learning strategies I would help would be if a student was really struggling on a topic, I would have them teach it to me the best that they could, and I would kind of help them fill in the gaps, because I know that sometimes they don't really know what they're missing until they kind of like fill in those gaps. And then I would also help with extra practice problems, and I would help if a student were falling behind or they really like to procrastinate. I would help them make a study schedule so that they wouldn't fall as behind. Because I know that if you fall behind in chemistry, it's a lot more difficult to catch up. And then I will show you my video or my problem solving next. Okay, so this is going to be my practice problem for today, and it's an electrophilic addition. So the first thing we want to do for these reactions is we want to determine what our nucleophile is, so what is our most electron dense, and which one is our most electron poor or our electrophile. So our nucleophile would be this double bond right here because it is the most electron dense, and we'd want to find our electrophile, which is this hydrogen, which is the most electron poor. So our nucleophile would attack our electrophile, and then we would bring the rest of these electrons onto the chlorine. So when we do that, this bond breaks and this hydrogen will attach to form the most stable carbocation. And so it would attach, if this was our molecule, it would attach right here and leaving a carbocation intermediate. Now, we could keep going, but since it's asking for the major product and this is not our most stable carbocation, we have to do a shift. But we have to determine what shift to do. Since we do have a hydrogen here, we are going to do a 1,2 hydride shift. If these three were all carbons, we would do a 1,2 carbon shift, or a 1,2 methyl shift. So we would move this hydrogen right here to form the most stable carbocation. And remember that a tertiary is more stable than a secondary. See right here, there's 2 carbons surrounding, and once we do the shift, it'll be a tertiary carbon. So then the hydrogen would just move here. Next, we would want to attack our carbocation intermediates with our chlorine. And remember, you can only do these shifts with the adjacent hydrogen or carbon or methyl group. So if you were to do a shift from here, say this was a carbon, you couldn't shift all the way there. You would have to only do here or here. And we wouldn't want to do here because that would make it less stable. So once we attack, remember that even though this question isn't asking for stereochemistry, that since it's a carbocation intermediate, our chlorine will attack 50-50 from the top or bottom, so that when we are drawing stereochemistry, we can draw our chlorine on both a wedge and a dash. So we could do this. And there you go, and that is the question. Thank you so much.